problem number 6 in the packet, you saw that you had to start with mass and find moles. That's what we're going to do here. Because chemists don't measure moles in the lab, they measure mass, right? Mass or volume. So here we go back to the deli, and we have a manager who has ordered 15.6 pounds of meat. And the question is, how many sandwiches can he make? And then we can also ask the question, answer the question, how many pounds of cheese do we need? So let's go back and take a look at what we knew about the sandwiches, right? 2 bread, 2 meat, 1 cheese makes the sandwich. We were given these amounts of what a slice of each were, right? Alright, so if we want to answer the question, how many sandwiches can you make? We're going to start with that 15.6 pounds of meat. Okay, so that's my given, right? I have 15.6 pounds of meat. And what I need to do is, in order to figure out, go from meat to sandwiches, what I have to use is these mole ratios, right? So I have to first convert the weight to moles. So what I know is this right here, right? 1 slice of meat is 0.075 pounds. Alright, so I know 0.0750 pounds of meat, right? I want pounds of meat to cancel. It's going to give me 1 slice of meat, right? 1 meat. And what I know is this should be 3 meat, right? I think I wrote this wrong. 3 meat is going to give me 1 sandwich, 1B, 2M, 3C. And if I multiply this out, I'm going to get 15.6 divide by 0.0750, which will tell me how many slices I get, which is 208. And if I divide that by 3, I'm going to get, I can make 69.3 sandwiches, bread, meat, cheese sandwiches. And of course, I'm really going to make 69 because I'm not going to make a third of a sandwich. Okay? So let's take a look at the next question, which is how many pounds of cheese would be needed. So I started with 15.6 pounds of meat. Actually, what I can do is say 69.3 or 69 sandwiches, right? I can start with either the pounds of meat or the number of sandwiches as my given, because both of them will give me the answer on how much cheese I need. So I'm going to start with 69 sandwiches. So if I have 69 sandwiches, this should be a 3, right? What I know is 1 sandwich requires 1 piece of cheese, right? And I know that 1 slice of cheese is 0.100 pounds of cheese. So what I'm going to end up with is 69 times 0.1, or 6.9 pounds of cheese. So when they go to the butcher, they should ask for 7 pounds. Okay? Pretty easy? Okay, so again, the process of stoichiometry is a process using a chemical equation to calculate relative masses into things that are weighable, right? Relative masses or volumes. So the equation can represent molecules, or it can represent moles, right? Moles of these things. But I can convert moles to grams, right? I know 2 moles of hydrogen, and if I have 2 of those, each weighs 2 grams, it's going to be 4 grams, right? So coefficients in the balanced equation give us the ratio of moles. Alright, so let's take a look at this problem. Several brands of antacid tablets use aluminum hydroxide to neutralize excess stomach acid. The aluminum hydroxide reacts with hydrochloric acid in your stomach to produce aluminum chloride and water. The question is, what quantity of hydrochloric acid can be neutralized, and then how many grams of water are produced? Alright, so we always start with the equation. So we have aluminum. This is going to bring back a lot of stuff you haven't done for a while. So aluminum hydroxide is what we're starting with. Aluminum is a +3. Whoops. Hydroxide is a -1, so I'm going to need 3 of these. Reacts with the hydrochloric acid in your stomach, HCl, and it produces aluminum chloride. Alright, aluminum is +3, chlorine is a -1, so I need 3 of those, and water. So I'm going to need to balance this. Let me see, I've got 3 chlorines here, so I'm going to need to make this 3, right? And now I have 3 oxygen. I'm going to need to make that 3. And if I do that, I end up with the right number of chlorine. And oxygen, I've got 3. Hydrogen, I've got 3 + 3 is 6. So that's all balanced, okay? I can do a voila on that. How much hydrochloric acid in grams can I neutralize from 0.75 grams of aluminum hydroxide? Okay, so I'm starting with 0.75 grams of aluminum hydroxide, and I want to know how many grams of HCl will be neutralized. Alright, so I first have to take my aluminum hydroxide mass and get that to moles, right? And what am I doing here? That should be a 3. And my molar mass of aluminum hydroxide is going to be 1 aluminum, which is 26.98, plus 3 oxygens, plus 3 hydrogens, and I'm going to use, add this up, and what I get for the molar mass is going to be 78.01 grams. 78.01 grams of aluminum hydroxide gives me 1 mole of aluminum hydroxide. And I'm trying to figure out how much HCl I can neutralize, so I have to convert from moles of aluminum to moles of HCl, and this is where I use the mole ratio. So what I know is 1 mole of aluminum hydroxide is going to neutralize 3 moles of HCl. But it didn't ask me for moles of HCl, it asked me for how many grams. So I need to convert this moles of HCl, so I need 1 mole of HCl, and that's going to give me, let me see, 35.5 plus 1, 36.1 36.51 grams of HCl. And if I multiply that out, I'm going to get, let me see, let's just make sure I cancel stuff. Grams of aluminum hydroxide, grams of aluminum hydroxide, moles of aluminum hydroxide, moles of aluminum hydroxide, moles of HCl, and I'm left with the units that I want. So my answer is going to be grams of HCl, and if I multiply this out and I want 2 sig figs like my given, it's going to give me 1.1 grams of HCl. And then if I try to answer the second question, which is how much water gets produced, I'm going to do the same thing. I'm going to start with 0.75 grams of aluminum hydroxide. I'm going to convert that to moles using the same molar mass for aluminum hydroxide to 1 mole of aluminum hydroxide. And this time I'm going from moles of aluminum hydroxide, the coefficient there is 1 mole of aluminum hydroxide, in this case gives me 3 moles of water. But I want to know grams of water, and what I know is 1 mole of water is going to be, let me see, it's going to be 18.02 grams of water. Let's make sure I can cancel stuff out. Grams of aluminum hydroxide, grams of aluminum hydroxide, moles of aluminum hydroxide, moles of aluminum hydroxide, moles of water, moles of water. My answer is going to be grams of water, and I want 2 sig figs like my given, so that's going to give me 0.1 0.52 grams of water. Not too bad. So here we are, a new problem. Alright, this is in your packet. I think it's number 4 on the worksheet 2. Okay, so during the process of anodizing aluminum, aluminum reacts with oxygen to form aluminum oxide. And if you have 6 grams of aluminum, how many liters of oxygen gas at STP are needed to complete the reaction? And then what is the mass in grams of aluminum oxide that will be produced? Okay, so let's take a look. First thing we want to do is write the balance equation, and to do that I'm going to start with aluminum. Aluminum, and it says it reacts with oxygen and it forms aluminum oxide. Aluminum oxide. Aluminum's a +3, oxygen's a -2, so I need Al2O3. And to get this balanced, let me see, this is an odd number, I'm going to have to double that in order to get it even so that I can do that. And then I'm going to need 4 aluminum, so that's my balance equation. Okay, so let's go ahead and take a look at the setup. Alright, so I'm going to start with my given, which is going to be 6.0 grams of aluminum. And let me see, so I have 6.0 grams of aluminum. And I need to get that to moles of aluminum, and what I know is 26.98 grams of aluminum is 1 mole of aluminum. But I'm trying to figure out liters of oxygen, so I need to get it first to moles of oxygen. So I need to look at the ratio of aluminum moles to oxygen moles, and what I know is 4 moles of aluminum will require 4 moles of oxygen. But I want to know liters of oxygen, and if you remember, 1 mole of any gas at STP, which is what it says here, is 22.4 liters. So 1 mole of oxygen is 22.4 liters of oxygen. Okay, so if I set this up right, I got grams of aluminum, moles of oxygen cancel, leaves me with liters of oxygen. If I multiply all this out, I will get 3.7 liters of oxygen. Okay. Alright, the second question is, what is the mass in grams of aluminum oxide that will be produced? So I'm going to do the same thing. I'm going to start with my given, which was, if you recall, was 6.0 grams of aluminum. So 6.0 grams of aluminum, and what I know is 26.98 grams of aluminum is 1 mole of aluminum, and my mole ratio is 4 moles, right, of aluminum. It's going to give me 2 moles of that. 4 moles of aluminum give me 2 moles of aluminum oxide. And I want grams, so I got to convert this aluminum oxide to grams. So 1 mole of aluminum oxide, that's 2 aluminums and 3 oxygen, and the molar mass for that is going to be 101.96 grams of aluminum oxide. Make sure I can cancel all of my units. Oops. And I'm going to end up with, I need 2 sig figs, just like my given, 11 grams of aluminum oxide. Okay.